Welcome to the Physics Tips for Cambridge Students YouTube channel. Today we are focusing on AS level physics practicals. Okay, so we're just going to talk about the tips that you are supposed to be very aware of. So first of all, I'm going to look at measurements. So when making measurements, you must always follow the precision of the instrument that you use to measure. Okay, so always follow the precision of the instrument that you use to measure. For example, if you use a meter rule, make sure that you express your results correct to 1 decimal place if you're measuring in centimeters, no decimal places when you're measuring in millimeters, and 3 decimal places when you're measuring in meters. Simply, you are measuring correct to a millimeter. Okay. So you're measuring correct to a millimeter in that regard. Right? Then, when you're using a micrometer screw gauge, so for a micrometer, make sure that you express your answers correct to 2 decimal places, that is in millimeters. If you want to measure using a vernier, you must always express your answer to 2 decimal places in centimeters. So that is where you are asked to record the reading. Make sure that you follow exactly what we have just gone through so far. So for a meter rule, I said that it must be correct to a millimeter. So which means 1 decimal place when you are dealing with centimeters. So for example, you're saying it is supposed to be 20.3. Okay. So for example, you can have 20.3 centimeters. So 20.30 is not allowed. Okay. It is not allowed. 20.3 centimeters. So your readings must be correct to 1 decimal place in centimeters. If you have decided to use the millimeter scale of the meter rule, recording to a millimeter, then no need for decimal places. For meters, since there are 1,000 millimeters in a meter, you need to express your answer correct to 3 decimal places all the time. Right? Then when measuring angles, okay, when measuring angles, you must always express correct to 1 degree. 1 degree. So no decimal places for angles. Okay, no decimal places for angles. So all the time it's just like e.g. 28 degrees. That's all. Not 28.1, 28.6, not allowed. So 28 degrees, 40 degrees, 39 degrees, 2 degrees, no decimal places when talking of angles. Then when talking of time, here, remember the stopwatch, most stopwatches, they give 2 decimal places. It's good to record the time, say for 20 oscillations, to correct to 2 decimal places. Very, very fine. No problem with that. And then 1 decimal place is also allowed. Okay, you can round up to 1 decimal place, but mostly we always record to 2 decimal places. So that is time for so many oscillations. Okay, let's say 20 oscillations. Now, for the time period, okay, for the period, remember, you've got to say divided by the number of oscillations, like divided by 20, we express to 3SF. Okay, 3SF, so which means period squared. So this is period T. Time for 20 oscillations, small letter t, please. So big T for the period, and then T squared 3SF again. Okay. So if you decide to record to 4SF for t, but make sure that for t squared, it's always 3SF. Okay, you have to drop an SF when you are squaring t. And it's very important to repeat your readings here when you're performing the actual experiment. So I'm going to be emphasizing the very fact of repeating your oscillations all the time, so that if you reduce random error. Okay, so all along we have been talking about measurements. Okay, measured values. Okay, so we've been talking about measured values. So these are the measurements we're talking about. So for a meter rule, for vernier, for micrometer, very, very important. For angles, and then for time. Now we want to go ahead and look at calculated values. Okay, calculated values. Now calculated values are always stated to the same number of SF. Number of SF is measured values. So always stated to the same number of significant figures as measured values. So suppose you had L, right? Suppose you had L is equal to 5.0 centimeters, right? So which means L squared will be equal to 25 centimeters. Because this is 2SF, so which means this also must be expressed to 2SF. So this is 2SF as well. Okay, so very important to do that. Express calculated quantities to the same number of SF. So you look at the significant figures. Remember, when we measured, we said this is correct to 1 decimal place, but this is 2SF in actual fact. So which means that L squared should also be to 2SF. Similarly, like I said, if period is, say the period is 3.04 seconds, so which means the corresponding t squared must also be to 3SF, the same value to 3SF there. Right, so I hope that makes sense. Right, I'll give another example, and then we are going to end our video right there when we're talking about that. And then in the next video, I'll focus on how to score good marks on a table, how to score good marks, as well as looking at graph work. Okay, so if L is equal to 23.2 centimeters, right? L squared is equal to 538.24. Now, looking at the number of SF, we've got 3SF this time. So this is to 3SF. So which means that this must also be to 3SF. So how do you make it go to 3SF? That's going to be 538. So suppose you're supposed to, so this is supposed to be squared. Okay. So suppose you are supposed to write this in a table, on a column table. You must make sure that you use 3SF there. So you look at the raw data, and then you express your calculated quantity to the same degree of accuracy. Now, I want to go over what we have done in this video. So we said that when taking measurements using a meter rule, you know the precision of a meter rule is 1 millimeter. So which means you must always record your values that is correct to 1 millimeter. So if you decide to use centimeters, it should be 1 decimal place, etc., etc. When using a micrometer, micrometer is stated in millimeters, so it's always to two decimal places all the time. So always record to be consistent with the precision of the micrometer. Then we have got a vernier in centimeters now, so 2 decimal places in centimeters. Then angles, do not put a comma or do not put fractions, do not put decimals. It's always correct to 1 degree. Then time, you could use 2 decimal places or 1 decimal place, that's fine. And then I also encourage you to repeat your readings all the time. Suppose you're working with current, you look at the multimeter that you are using, okay, so a digital multimeter, and then if it's to 2 decimal places, you record exactly as you see. If it's an analog meter, you should also record exactly as you see. Okay, so it must be consistent with the limitation of the instrument itself, the smallest degree that the instrument can measure. Then I said that calculated values should always be stated to the same number of significant figures as the measured values. So you should go back to your measured values and check, and then for consistency's sake, you state your calculated values to the same significant figures. I think that is all for this video. Please consider liking and sharing, as well as subscribing to the YouTube channel, Physics Tips to Cambridge Students. Signing out.